We're going to briefly talk about classifications of organic compounds and functional groups. What I would like you to recognize is that a functional group is a set of atoms typically bonded to some hydrocarbon or bonded to an organic molecule that's going to give it certain properties, right? It's going to have chemical reactivity. It's going to give it properties to that particular molecule as a whole. And so we like to sort of identify what these regions are on a molecule. And so those regions we call a functional group. And we've got in the second column of this chart a variety of different functional groups that we'll look at. I want you to realize that the functional group can also correspond to how we classify or name the type of organic compound that you have. So for instance, the alkane functional group, we call that organic compound an alkane. An alkene functional group, so when there's a double bond present, like in this molecule of ethene right here, we see that as well. That double bond being present in the molecule tells us that the functional group alkene is in our molecule, and we can classify the organic compound generally as an alkene, right? So the functional group and the type or classification of organic compound can be the same, right? Like we see with these first three, alkane, alkene, alkyne, as their type of organic compound, but also the name of this particular functional group that we're looking at. As soon as we move into other areas, other organic compounds like alcohols and aldehydes and ketones and carboxylic acids, we see that the functional group takes on a different name. So for our alcohol, with an alcohol, we notice this functional group present on our molecule. If we see an OH group present, which the OH group is called a hydroxyl, that's its functional group name. If a hydroxyl is present on an organic molecule, it means we can classify that organic molecule as an alcohol. That's what it allows us to identify. And we see that by, in this example here of ethanol, where we've got our OH present on that, attached to that set of carbons. And so that's our ethanol molecule. And we can tell by the name too, because you'll notice in the name ends in OL. So alcohols typically will have OL at the end of their name, right? So all of these sort of pieces as we get into this naming puzzle and what functional groups are present and the type of organic compound that we have are going to work together here. Our aldehyde, our next organic compound, aldehydes. Aldehydes have a carbonyl functional group. Now, the carbonyl functional group is a C double bond O. But if the C double bond O is at the end of the chain, that's when that carbonyl group is going to give the molecules the properties that we classify as an aldehyde. So that molecule we refer to as an aldehyde, and you'll notice that the ending of the name becomes Al. So in this example here, you can see the C double bond O at the end of the chain. So the carbonyl or carbonyl is at the end of the chain, and the end of the name becomes Al, so ethanal, because we have an aldehyde molecule. Okay. Now, if that same functional group, the C double bond O, that carbonyl group, is located within the chain, just like we see in this next example, see how there's 3 carbons? And so within the chain, that's where we see the carbonyl. It's right there. Okay. That location of that functional group, the carbonyl functional group, is what gives us a molecule classification or molecule type known as a ketone. Okay. And we can identify ketones also by their name because they typically end in ONE. So you'll see this example is propanone. Its actual common name is known as acetone. And that's your simplest ketone that you can find. So these types of molecules, aldehydes and ketones, both have the same functional group, the carbonyl. It's just where the carbonyl is located. If it's at the end of a chain, we then classify it as an aldehyde. If it's within the chain, then we classify it as a ketone. A few other functional groups just to recognize. Your carboxyl. So the carboxyl is kind of like a combination of the carbonyl. So there's the C double bond O and the hydroxyl, right? So when we see that at the end of our molecule, that is a carboxyl functional group. And the carboxyl functional groups mean that our molecule can be classified as a carboxylic acid. Okay, and in the name, you'll see oic acid at the end, just like we see in this example. So we've got that C double bond O with the OH, right? And that's always going to be at the at one of the ends of your molecule. And that's your carboxyl functional group, which then classifies this entire molecule as a carboxylic acid. Our next set of functional groups, you'll notice that the functional group name again matches what the name of the or classification is of the organic molecule. So if we have an organic molecule that's classified as an ester, you're going to see an ester functional group in it. The ester functional group is a C double bond O with an O bonded to it, but you'll notice that a carbon chain is built off of each of those ends. So from the carbonyl end, there's going to be carbons that continue, and off of that oxygen, there's going to be carbons that continue. So when we look at this particular molecule right here, we've got our C double bond O. Off the oxygen is this portion of the molecule, and off of the carbonyl, we have the rest of it, right? So you'll see esters, these ester functional groups, you'll see the name at the ending, they'll say 08. And that's how we can tell that a ester is present, okay? So in this one, ethyl methanoate, they actually name the part off the oxygen first, and then they name the part with the carbonyl second. So just a neat little thing. Now the ether, so molecules that are considered an ether will have an ether functional group, and that means you have an oxygen within your chain, your hydrocarbon chain, and you'll see oxy in their name. Now, oxy is actually kind of in the middle of the name. So they're going to name one piece of the name, then they'll name the oxy part for the ether. So in this example, there's the oxy part for the ether. So they're going to name one part of it first, then you'll have the oxy, and then they'll name the other part second. Okay, and they usually, with these ones, they'll name it as the short chain first, then oxy, then the long chain. But if you see oxy in that name, recognize that we've got an ether functional group. We could talk about that molecule as being an ether. Okay. Amines have nitrogen. So these are nitrogen containing. So if you have nitrogen branching off your hydrocarbon chain, you have an amine functional group, which then we classify the molecule as well as an amine. Okay. How we see them in their names, when we're looking at the name, you're going to see amino in the name. Usually it comes before the root part of the name. So in this case, here we've got our nitrogen attached to our carbon chain. There's our carbon chain. So we see that amino, and then the rest of the carbon chain is named there. Right? So these ones you'll see amino near the beginning of the root part of the name, and the amine functional group is that nitrogen attached, which could have hydrogens. Also note those hydrogens attached to the nitrogen could be replaced with other carbons, other carbon chains coming off of there. So as long as basically you see that nitrogen, you have an amine. Okay. The last functional group we'll see will be amides. Amides have the nitrogen component, but they also have the carbonyl component. So this is your amide functional group, the C double bond O with the N right next to it. Okay, and if that functional group is present, we classify your molecule as an amide. And how you can tell by the name is you actually see amide in the name. So when we look at this example, we've got the nitrogen right bonded to the carbon of the carbonyl. So there's my amide. And you'll notice that in the name, we can see amide there at the end of the name. So recognizing what functional group is present, what type of molecule or classification of molecule is pretty important as we start to look at properties of these things and how they behave and how naming systems start to work for them, right? So recognize for those functional groups that match the name of or classification of the organic molecule, right? So ester functional group, ether, amine, amide, they match the name of the classification, but there are some like hydroxyl and carbonyl and carboxyl where they don't match the name, right? The types of molecules are different. So an alcohol, an aldehyde, ketone, carboxylic acid, right? So understanding what a functional group is, recognizing those on a molecule or maybe in the name, how you can tell which functional group is there and what type of or classification of organic molecule is an important thing to be able to do in organic chemistry.